Lesson 7.1 talks about the areas of parallelograms and rhombuses. So on page 387, Sophia drew the grid below and plotted the points A, B, C, and D. Connect the points A to B, B to C, C to D, and D to A. Then find the area of the shape and explain how you found it. Using the same grid, move. Okay, so we're going to find the area of this first of all. Area we've talked about before. Area of a rectangle is length times width. So to find the area, one way we could just count how many squares there are. That's quite a few squares to count though. So what we may want to do is just count our length and our width here. So just count how many squares we have going across and how many squares we have going up and down. So if we count this, we've got 19 squares going across, we've got 12 squares going up and down, and we would multiply. 19 times 12 would give us the area of a rectangle, which would be 228. This is square units, most likely square centimeters, usually centimeters for a grid like this, but 228 square units would be the area of our rectangle. The next thing they ask us to do is to move points B and C 4 units to the right. So if we take B, we go 4 units to the right. Would put it there. We'll call that B prime since we moved it. And then C 4 units to the right as well. Would put it here. And then it says connect the points to make a new parallelogram. What's the area of this shape? So we connect here A to B prime, I should say, B prime to C prime, C prime to D, and then D back to A. And what you might notice here is we've got some little triangles that are created. So we got a little triangle here that we cut out, right? We lost that area, but then we've got the area over here that we got added. So those triangles, you might notice, are identical to each other. So the part we lost and the part we gained are the same, means that the area of this parallelogram that we created actually would also be 228 square units. And this will bring us into our formula we'll talk about for the area of a parallelogram, which is to take the base times the height. So example 1 just kind of talks about what we were just mentioning. We take a parallelogram. If you take part of it and move it to the other side, that creates a rectangle. So instead of length and width, if we call the bottom part the base, up and down, instead of calling that the width, we call that the height. The area of our rectangle would be base times height. Well, our parallelogram, if we just move that piece, the height obviously is the same. The base is actually the same also. So instead of length times width, we look at it for a parallelogram as base times height is how we find the area. So that brings us to our formula here. And again, in this formula, B is for the base, H is for the height. And here's our formula. Area is base times height. And this formula will be given to you. You'll have a reference sheet that you can use when you're taking your tests, and that'll be the same reference sheet you'll be able to use when you take I-STEP in the spring. And one thing to mention here that we'll need to note as we go along on these problems, the base and height meet at a right angle. So we're always going to make sure that those meet at a right angle, at a 90-degree angle, the base and the height, when we decide what those are. So here's the reference sheet that we'll be using for these. If you'll notice, two things we've already talked about today. Area of a rectangle is length times width. Area of a parallelogram is base times height. Now, they don't give you pictures or anything, so the formulas are there, which is very helpful for us, that we don't have to remember that. But you still need to remember, for example, on a parallelogram, what it means base and height, what B and H actually represent. We'll be working with some of these other formulas as we go through the rest of this topic. So to try it, they want us to find the area of this parallelogram. First of all, just starting out is our formula. Area is base times height. I'm not sure why they're using their multiplication symbol here, because we've talked about not using that, but anyway. We can see on this problem, the base of this parallelogram is what? 7, and the height is? Okay. Again, notice those do meet at a right angle, so it's going to be a matter of just multiplying those together. When we multiply these, remember your decimals don't have to be lined up when you multiply, just when you add or subtract. So we multiply those, and then we need to move our decimal over just one place to the right, or to the left rather, sorry. So that would be 31 5/10. So the area of a parallelogram is 31 5/10 square centimeters. So here's a way of writing that without having to write out the word square centimeters. You can just do the little symbol like they've got in your book there.